In the previous video, we have implemented our sense of sight for our enemy, so he can discover if the player enters his area of vision. And now we need to focus on the finite state machine implementation, because we want to implement some behaviors and we want to switch between those behaviors. So let's talk about what the finite state machine is. Finite state machine is a technique to make decisions. Basically, it allows our NPC to switch between states depending on what is going on in our game world. Well, let's say we start in the idle state. We have chase state and wander state. How do we decide if we want to choose one or the other or stay in the idle state? Basically, we can create conditions. So those are the conditions, the text near the arrows. First one we have, is player spotted? Well, if the enemy spots the player, so if our agent has the target, we can move to our chase state. On the other hand, we don't want the enemy or NPC to just stand still and do nothing. We can quite easily implement a simple wander state. So wander state makes our enemy choose a random direction and just simply walks towards it. So we have our time condition, and after some time our enemy will start wandering around. Now we could make a lot more here, so check if there is collision in front of him and just move and turn around. This is the simplest version. We will just choose a random direction in some brackets of like 45 degrees or something similar, so to not make a big turns, and we will just walk a couple of steps forward and stop and then change again the direction. And in the wander state, again, we will ask, is player spotted? If it is, we are going to move to the chase state. And in the chase state, we only care for one condition. Did we lose the player? And if we did, we move back to idle, to stand still for a while. We are making the illusion that the NPC is intelligent by providing a simplest possible solution, so the simplest states, and making this impression that our enemy is standing there and looking for the player, still hoping that he finds him. So as I said before, we have three main parts of our finite state machine. Our states, so the behavior that our player can do. And transition, so the way to connect different states, and condition, so the transition will ask, is my condition met? And if it is, then we move to my second state or my target state, and if it isn't, we will stay in the current state and perform the current state's action. So let's create a new folder in our AI. Let's call it a state machine. Okay, and here inside it, let's create a first script. So let's create C# script called condition. Let's open it up, and let's delete the mono behavior inheritance. Let's change it to scriptable object, and let's make it into an abstract class. So we will inherit from scriptable objects, so we can easily create our conditions through the editor. And what we will want to do here is create one method called public virtual bool. So we'll return boolean value test. We will pass the agent, so our data from the game world that we have access to, that our AI system has access to, and we will return false. So the basic condition just returns false. Okay, let's go back to Unity. Next, let's create a new C# script, call it state. And let's open it up. This will be in fact a mono behavior, and first thing we need to call is require component, and type of, and agent. So as you might remember, the vision script requires agent, so we make sure that the agent is present in every component and in every game object that has any state by requiring it from the start. Okay, now we will need to access this agent, so public agent, and let's call it agent. Next, we will need to have a list of transitions. So transition will be created in this class as a public struct. And let's call it transition. And let's create public condition and public state target. And what we will want to do is create an attribute here, serializable. Alt Enter, and we'll need to be using system. So now this will be visible in inspector. Okay, let's go up. So as I said before, we will need to have a public list of transitions. So list of transitions equals new list of transitions. And the last thing we need is protected universal movement script movement controller. So this will access any type of universal movement. So for the player it will be player movement, for the enemy it will be skeleton movement. Okay, now we need to have awake. Here we'll need to call agent equals get component of type agent. So we will have access to the state of the world. Great. Now we will need to create some methods that we will use in other states. So public virtual void on enable. So we will create virtual on enable and virtual on disable. Let's copy this. On disable. We will disable the state that is currently used and any other state that is unused, and enable a new state on transition. Now this technique is taken from Unity 2018 Artificial Intelligence Cookbook, so if you want to learn more about AI, I encourage you to check out this book. Okay, so basically each state will be able to preset some settings in on enable or disable some settings on disable. We will need to call public virtual void update. Okay, and last thing we need, let's delete those remaining methods. We will need a fixed update, so let's call fixed update. And in the fixed update we will call each transition. So for each transition in our transitions, and here we will call if transition dot condition dot test, and we will pass our agent data. So if the condition is true, we are going to call transition dot target dot enable equals true, and this dot enable equals false. So what we did here, we have enabled the different state that is a component on our game object, and we have disabled this state, which is also a component on our game object. And in this way, the update function for the currently enabled state will run, and for this state from which we are coming from will be disabled, so it will run no longer. So now we can call return. So with this state script done, we can create our custom states by extending this state. So let's go back to Unity and let's start from creating a custom condition. So first let's create a new C# script. Let's call it a site condition, and another one, create a script, a lost site condition. This name is in the context of the player, so lost site of the player, and I can see player. Okay, let's open the site condition. Here we are going to delete the content of this class and inherit from the condition. And at the top we are going to call the attribute create asset menu file name, and it will be called site condition, and a menu name. I will create a SVS, Sunny Valley Studio AI, conditions, and a site condition. And we can make it into lowercase. Okay, great. We will override the test method and we will return the agent dot target. So if the target is null, it will return false. If it is not null, it will return true. And this create asset menu will allow us to create the condition from the Unity menu. So let's minimize it. And we can now left click and create, and we should have our menu. If everything compiles. Okay. SVS AI conditions site condition. Okay. Next, let's open lost site condition, and we can do the same thing. We can go to site condition and copy this menu, create asset menu attribute, paste it here, change mono behavior to scriptable object, delete the content, change the site condition to lost site condition, and conditions lost site condition, override the test. We don't need scriptable object, we need condition. So we can override the test and we can return if agent dot target is equal to null. And that's it. So save it, minimize it, and we can create another condition through the menu, and it needs to compile the game. Okay, and we can see lost site condition. So it's pretty easy to create new conditions based on what you want to check. But now for it to work, we need to create a state. So let's create a new C# script and let's call it chase state. Let's open it up. Let's delete the content of this class and let's inherit from state. So what we will need to do here? Well, first of all, we need to override on enable. Okay, and not on disable, on enable. Okay, and we will want to access the indicator. So if you go to Unity project, our skeleton has an indicator that just indicates that it is aroused and it wants to find you. And if it is gone, then you know that skeleton is not aware of your position. So this is a simple feedback for the player. So here we are going to create a public game object indicator, and in onEnable we will want to find if indicator, then we are going to call indicator set active to true. Okay, and let's copy this, because now we will want to call override on disable, and we will want to check if indicator exists. We will want to set it active to false. This way we will disable and enable indicator on the exiting and on entering of our player into the sight range of our skeleton. And last thing we need to do is override update. So in update everything will happen, because we are going to check if the agent target isn't null, then we will start chasing the player. So let's delete the base update, and instead we are going to call if agent dot target equals null. So in case it is equal to null, we will return. In the fixed update, the state base class will change the state because the agent.target is null, and the lost site condition will trigger. So otherwise, if the agent.target isn't equal to null, let's call var direction equals our agent.target.transform.position minus our game object.transform.position. So we will get the direction. Next we will call direction.normalize to get the normalized version of the direction. Okay, and we want to call movement controller.move, and the naming of the vector3 is pretty bad, so let's go to universal movement and let's change it global direction to local direction. Okay, because what we want to do here, let's go back to chase state, let's call it again. We can see that we need the local direction, and to get the local direction, because the direction that we currently have is in global coordinates, we will want to call game object.transform.inverse transform direction, which, as you can see in the help tip, it transforms a direction from world space to local space, and that's exactly what we want. So we want to call our direction that we have found. In this way, our enemy or our NPC should look at the direction of our player and should follow it. So that's all for the chase state. Let's save it. Let's go back to Unity. Okay, so let's now make it work. So let's drag chase state onto our skeleton. Oh, sorry, not indicator, our skeleton. Okay, we can see that it wants an agent, but we have agent, so we are good to go. The indicator, we can drag our indicator from the skeleton object, and transitions. We have 0 transitions, so it will not change to any other state. So now let's press play, and let's see what happens. And there is no exception. So we have missed something. Let's stop it, and let's go to our state. And we can see that our universal movement controller was never assigned. So let's go to awake and equals get component universal movement. Okay, great. Now we should be good to go. Okay, so let's play again. And we can see that because there is only chase state on the skeleton, the indicator is always on. And we can see that skeleton has started chasing us. But there is an issue. It doesn't stop the animation. It constantly walks. That's why we cannot leave it like this, because it still will chase us in any instance, but it will never stop. So that's why we need our idle state and our wandering state. So let's get to implementing those in the next video.